Start by reading the question. It asks us to pick the molecule that can most accurately be described by multiple resonance structures. To do that, we should plan to draw the Lewis structures, showing all the electrons and formal charges, and examine the possibility for resonance structures. So let's solve it. Carbonate has one carbon atom with 4 electrons, 3 oxygen atoms with 6 electrons each, and a charge of -2, so 2 extra electrons. There are a total of 24 valence electrons. Calculate the number of valence electrons for the other 3 molecules in the same way. To draw a Lewis structure, start by connecting the atoms with single bonds. Then arrange the remaining electrons around the molecule to fill the octet of each atom until you run out. In this case, carbon still doesn't have an octet. Use one of the oxygen lone pairs to form a double bond to the carbon atom and complete the octet. Finally, determine the formal charge on each atom. Follow the same steps for trifluoroborate, but in this case we don't need to form a double bond between a fluorine atom and a boron, since fluorine is very electronegative, and boron commonly has an incomplete octet. All the atoms are neutral. For triiodide, after filling the octet of each iodine atom, there is still one lone pair left to place. We must exceed the octet of one of the iodine atoms. If we put the extra lone pair on one of the terminal iodide atoms, that atom will have 9 electrons and a formal charge of -2. If we put the extra lone pair on the central iodine atom, the atom will have 8 electrons and a formal charge of -1. So put it on the central atom to minimize the formal charge, and assign the negative charge. Carbonyl fluoride is similar to carbonate. Form a double bond between oxygen and carbon to fill the octet. Do not form the double bond between fluorine and carbon, because fluorine is more electronegative than oxygen and less willing to share its electrons. All atoms are formally neutral. Now look for possible resonance structures. In the first Lewis structure, any one of the 3 oxygen atoms can share an extra pair of electrons with carbon, so this molecule can be described by 3 equivalent resonance structures. This may be the correct answer. Check the other options to see if any of them are better. We decide that there are no boron-fluorine double bonds in the second molecule. Remember, you can't break or form single bonds to get new resonance structures, so there are no possible resonance structures here. The only way to form resonance structures for triiodide is to form double bonds between iodine atoms. This breaks the octet rule even further, so this one's no good. Finally, we already decided that fluorine-carbon double bonds are much less likely than oxygen-carbon double bonds due to the electronegativity of fluorine. So although you could describe this molecule with multiple resonance structures, they would not be as useful as they are for describing the carbonate ion. The answer is A. Finally, check your work. Let's just draw the other 2 Lewis structures for the carbonate ion. 1 and 2. They're equivalent, just rotated by 120 degrees each, so move on.